In this video, we're going to continue topic 3.1, the chain rule. And in this video, we're combining the chain rule, and it looks like we've got some division going on. So we're going to use the quotient rule and the chain rule. I'm noticing that my red is going to be this e to the 4x, and my green is going to be sine of 2x, and they both have a chain rule in them. So I'm going to kind of do some side work here and before I try to take my quotient rule derivative. So I'm going to call g equal to 4x for lack of anything better. I see that my u in that is going to be 4x, meaning that u prime would be 4. So I'm going to do my chain rule. I'm going to replace my 4x with a u. I'm going to start taking the derivative of the outer, which would be e to the u. Multiply that by the derivative of the inner, which is 4. And so we've got, I'm going to replace, so we've got 4e to the 4x when I replace the u. So that's the red derivative when I need that. My green derivative, I'm going to use h. Oh, I've already got h. Let's use f. So f equals sine of 2x, meaning that I've already used u, so I'm going to use w is 2x. And then w prime, my derivative of my inside is 2. I'm going to replace my 2x with a w, take the derivative of my outside function, which is cosine w, multiply that by the derivative of the inside, which was a 2, and then we're going to replace that with 2 cosine of 2x. All right, so now let's come back and let's actually do our quotient rule over here, now that I know what my derivatives of my red and my green are. So h of x equals the derivative of the red, which is 4e to the 4x, times the green original, so sine of 2x. We're going to subtract. And then I'm going to take my red original, which is e to the 4x. Parentheses around this don't hurt, okay? And then the derivative of my green, which is 2 cosine of 2x. And then that's all over the original green squared. And from there, you may have to simplify a little bit more. I'm going to choose not to on this one, but you might have to go a little simpler and do some more algebra. All right, let's look at 35. So it looks like I've got a quotient rule again. So my red is the numerator, my green is the denominator, but look at both of them have a chain rule going on. So I'm going to go ahead and do my chain rule off to the side here first. So for my red, I'm going to call that g for lack of anything better. And I'm going to say that g is equal to the 3x minus 1 cubed. Then my u value would be, my inside function would be 3x minus 1, meaning u prime equals 3. I'm going to rewrite the g. So g equals u cubed. So now I'm going to start taking the derivative of the outside function, which would be 3u squared. Multiply that by the derivative of the inside function, which we know is 3. Now we're going to clean it up. So the derivative of g would be 9. And instead of u, we're going to write 3x minus 1 squared. Now we're going to do the green. I'm going to call that one h. So h is going to be 2x plus 5 to the 4th. I recognize that I have an inside function. I'm going to call the inside one w. W equals 2x plus 5. So w prime is 2. We're going to replace my orange with w to the 4th. I'm going to take the derivative of my outside function, 4w to the 3rd. I'm going to multiply it by the derivative of the inside, which is 2. We're going to do a little bit of cleanup and replacement on that. So it's looking like 8. And then instead of w, we're going to write 2x plus 5 cubed. All right, now let's go back and do our quotient rule. So k of x equals, all right, the derivative of the red. The derivative of the red is the 9 times 3x minus 1 squared. I'm going to keep the green exactly the way it is. So 2x plus 5 to the 4th. We're going to use a subtraction sign. I'm going to keep the red exactly the way it was originally, which is 3x minus 1 cubed. I'm going to take the derivative of the green, which I found to be 8 times 2x plus 5 cubed, all over the original green 2x plus 5 to the 4th squared. I am going to choose not to simplify it. I could do some weird factoring stuff. I'm going to choose to just leave it as is on this one.